Well, let's look at this multiple choice question. This got a galvanic cell, a cell that is going to produce some flow of electrons for us by a chemical reaction. We've got our little voltmeter that can measure the volts, and we've got a switch here that can complete the circuit so that both the silver and the manganese ions, which are here, can try and grab some electrons. Now look here to see how good they are at grabbing electrons. Here, silver ions will grab an electron with a relative potential of 0.8 volts. Now, manganese can grab electrons too. It'll pull in electrons with a relative voltage of negative 0.76. That means it's negative 0.76 compared to hydrogen. Not that it's negative, it's just as a relative number, just like negative 5 degrees Celsius is 5 degrees below zero. This is negative 0.76 volts below hydrogen's reduction potential. Well, obviously, the silver ions are better at pulling electrons. These silver ions can end up pulling on electrons, and when they do so, they will pull them from the manganese electrons. So the manganese, which is here, is going to lose its electrons and turn into manganese plus 2. The Mn plus 2 basically loses. It can't pull electrons from silver. It can pull electrons from other stuff that have lower relative voltages if you're having manganese pull against something else. But in this tug of war, the top reduction value is going to end up winning. And we would have the reaction going like this. Silver ions turning into silver. That's a reduction. But whenever you have a reduction, you also end up having to have an oxidation. So this manganese is going to be sacrificed. This manganese, let me get my eraser here, is going to start disappearing and corroding away and turning into manganese plus 2 ions in solution. This 1 molar manganese plus 2 is going to become 1.1 molar, 1.2 molar, 1.3 molar. And the silver ions are going to be removed. They're going to be turned into metallic silver. And we would have pretty little silver crystals forming here on our silver bar. I mean, the silver bar is not going to do anything. We could replace that silver bar with a platinum bar or a graphite bar, anything that's non-reactive. You're going to see pretty little crystals of silver form. One of my favorites is silver forming. In this case, they're forcing electrons onto the silver ion that's in solution. And here we've got silver plus 1 ions gaining electrons. And let me move this forward a little bit, time lapse. And you'll see these little silver ions, which are invisible in solution, gaining electrons to become metallic silver. That's a beautiful reaction. We'd end up having that happening on this silver cathode where reduction takes place. Okay, now, big rule, whenever reduction takes place, oxidation has to happen. You can't have reduction without oxidation. I mean, you got to get these electrons from somewhere, and they're getting them from the manganese. Now, when the manganese oxidizes, when it goes in this direction, it gives away 2 electrons. Oh, by the way, so what's happening is silver ions are going into silver, turning to silver. So we know this answer is going to be wrong, without doubt. Now we need to balance things because the number of electrons lost, oxidized, are going to have to be obtained, and they're going to be given to the silver. These 2 electrons are going to be here. But we only have 1 electron, so we're just going to have to take this whole thing and make it so that there are 2 silvers picking up these 2 electrons and making 2 silver ions. So this is sort of a neat deal. For every 1 manganese atom that is sacrificed to turn into an ion, we get 2 silver atoms as result. So our balanced reaction has got to be 2 silver ions gaining 2 electrons, making 2 silver atoms, and 1 manganese giving up its 2 electrons. Okay, I think that explains it.